this, creating this text node. And these are all these standardized calls. Then append child now appends the text node with hello world to the paragraph, and then we append the paragraph to the div that was here in the target. And when you do that with a larger amount of user interface, it is very, very, very tedious. The library lets you do everything. It's just not very much fun. And that was the original motivation behind jQuery, that jQuery just gives you a nice shorthand, and they do the DOM stuff behind. So if you use jQuery, you would write the magic symbol $, and inside there you would write a string such as P, and that would tell jQuery to make a new paragraph node, and then you can put a text, and then that would tell jQuery to append a text node to that, and then you can append that to whatever. So you see the code, the complete code over here, with only one difference, and that is that instead of using that nifty $, they use the call to jQuery. And I had the very same reaction as you had when I saw it. I said, well, why didn't they just use the $? And I tried it out just to make sure whether it would work, and define $, as an alias to jQuery. But of course, it is true that the JVM says you're not supposed to use the $. We can use it for any purpose we want. And I guess the same thing would be true in the JavaScript code generation. They just figured the $. Wasn't the right thing. I tried a few others. I tried a £, and it didn't work because that's not a symbol. You can only use things out of certain Unicode classes. And I tried a couple of other things that I thought were perfectly cute that did work, but whatever. They just use the token jQuery. If it bothers you, it's easy enough to come up with your favorite one-letter abbreviation for it and make an alias, and it of course works. The one thing that is not so nice about this is that you lose a lot of type safety this way. So the jQuery, if you've ever written anything with jQuery, then you know that the $, is super powerful, right? You can give it strings of 10 different kinds, and it interprets them in 10 different ways, and it's all fine. It's very convenient in a way. But if you make a typo, then of course it never gets detected until runtime, and then you scratch your head. And that's the opposite of what type safety should be about. So jQuery, by its very design, is probably never the greatest target if you want type safety. So the author of this, not the author of Scala.js, but the author of this tutorial, he himself seems to be incredibly productive. So with his own hands, he came up with a different library, the Scala tags thing. But because it's only him who's done that, and I've never seen anyone else use it, I didn't put it into the tutorial. So I stuck with jQuery because I figure most of you either know jQuery or will know it soon enough. It's hard to avoid in practice. But that might, in the long term, be the better way to go, because right now by just going to jQuery, we're not getting a lot of mileage out of Scala. So the other thing that you want to do is when you write a JavaScript client, you want to make calls to the server, get some information from the server, update your user interface accordingly. And so those clients are usually done through the AJAX channel. And one can, in fact, make in Scala the call by using some AJAX object that they define. And so then the syntax is just Scala as opposed to the usual JavaScript callback. So you have a URL, and on success, you get some answer back. And out of that answer, then you progress. And so here the answer is in text. And so if that's what your server gives you back, then that's fine. So on the server side, there's not any work you really have to do, because you don't have to, you just write a handler for this. And you'll see that in the lab, where we're going to be taking essentially the exact same server that we had in the last lab for the to-do list, and we'll turn that into something that can be reached through AJAX. So this is just a GET request. You might want to have other requests, and there are versions for that as well that we're not exploring in this lab because that's not very well thought out. So it would be nice if there was a very simple way of making post, put, and delete requests, and they just haven't written the pieces of the library to support that yet. Then we're going to be using a very simple version of JSON where to move the data back and forth. So it's customary to use JSON in JavaScript. Of course, that makes perfect sense. It's easier than XML. It has the structure that you need, and in JavaScript, it's easy to consume and generate. Minimally, we're going to be using a thing called JSON parse to parse out the JSON. And that's what the tutorial kind of recommends to do as the first level of attack. But again, when you do that, you're going to find out that now the type safety gets in your way. So when you use plain old JavaScript, it's easy enough to consume JSON. You now get a JavaScript object. That was the whole point of JSON. And then you can just fiddle around in it. And you don't expect any particular type safety. But when you do this in Scala, then the response object that you get has to have some kind of type. What they did is they give it a type called js.dynamic. Since fairly recently, Scala has a dynamic type where you have an odd mixture of static and dynamic typing. When something is dynamic, then you can, at compile time, write something like this, even though the compiler doesn't know that .tasks never necessarily exists. So it's like in a dynamic programming language, like in JavaScript or in Ruby. This just means give it a good try, and hopefully there will be a .tasks at runtime. Yeah.
Is there a way to put some verbatim JS like you would put ASM in the C file?
No, that might be an interesting.
Yeah, you could use the missing calls from Ajax.
Yeah. No, the calls are there, but they just have icky syntax. So the same calls with the same icky syntax do exist.
Oh.
But if you want to make I tried to make a post request, and it was beneath my dignity to figure out the details. I mean, what it should be is I should be able to say ajax.post, give a URL, give a map of the name value parameters, but it wanted me to start to URL encode the map. And I said, life is not worth living if that's what I have to do. Undoubtedly, this kind of stuff can be added on at any time. And so I didn't want to uglify the lab with that. So what I did in the lab is instead I just made everything into GET requests and encoded the parameters in the request. But that doesn't scale, right? If you have a more complicated form, you want to be able to do posts. And yeah, but you can certainly do everything. It just wasn't pleasant. And so I figured we'll wait for that to be pleasant. So back to this part here. So when you get a JSON thing back, you get an object where you can kind of work like it is in JavaScript because of this dynamic stuff. So you can say, give me the value of the tasks field. It'll compile, and hopefully there will be such a field at runtime. What you get back is another thing that is one of those dynamic things. And that's all good. You can use this to dynamically get your way through the JSON tree of the object that you get back, except when one of them was an array. And so that's naturally happened in the application that I had. And at that point, maybe there's a better way of doing it, but they didn't do it. Then I had to actually make it into an array, and I had to use as instance of with a really ugly cast. And I didn't like it because now I had to do what I felt was gratuitous typing. That in JavaScript you never have to worry about any types because everything is dynamic. In Scala, a lot of types are inferred for you, but here you kind of get the worst of both worlds. You can make type errors, and you still have to give a bunch of type information. So my strong feeling was that this part of the library could need some love and care to be more usable. Now, what the author of this tutorial says is they say you shouldn't be using this raw stuff. You should be using a library that converts between Scala classes and JSON. And that is certainly true. So when you do that, life gets easier. But then I said, well, which library should you use? There is a standard one that everyone uses. That one doesn't work with Scala.js because it uses reflection. And so this fellow, Li Hao Yi, he then wrote his own, and again, it's only him who's supporting it, so I didn't yet want to put it into the lab. So I just want to point out that right now is still a bit of a weak point. So the one that he wrote is this thing that he calls MicroPickle. That will surely do the job for today if you wanted to do a project with it, so by all means do it. But who knows what's going to happen with that thing tomorrow. So also the jQuery integration, I feel if someone had a bit of a look at seeing it here, like the 10 different kinds of things that you do in a jQuery selector, and made Scala, if a Scala facade over that, you could have a perfectly nice interface to jQuery that's also type safe, but it would take someone some amount of time to design such a thing, and that hasn't happened. Then when you get into jQuery UI, if jQuery itself doesn't really help you make pretty user interfaces, it helps you to navigate the DOM tree more easily and to callbacks and stuff. But on the user interface level, there's a bunch of solutions. One of them is jQuery UI. And so if you wanted to do fancy progress bars or autofills or something like that, you need a UI library. And again, someone would then need to build the bridge from Scala.js to those libraries to make that really convenient. With form handling, you've seen a little bit how Play makes an effort to mediate between the name value pairs that you have in forms and Scala objects. Something like that, might also be a nice thing to have. Right now, there's zero support for form handling, of course, in Scala.js. And so that's something that would be work for the future. Validation, the same thing. There's no work at all. So I guess the idea is you could then use some library that does something like that, and again, then you would need the bindings for that. Right now, there's no IDE integration worth talking about, right? There's nothing in Eclipse where you can easily do any of this stuff. Like someone was asking about the debugger, none of this stuff exists. But there's no technical reason why this stuff couldn't come. So if the basic idea of generating JavaScript code with a high-level language were to become the thing, whether that's with Scala or with Dart or with some other language, all of those things will undoubtedly come, and they can come very quickly. So I think it's a technology that really shows pretty nice promise of being able to write both client and server-side code with the same language. And Scala is doing better than, certainly better than Java. No one's working on this stuff in Java. You could imagine it. What about Dart, for example? And that's possible, but Dart is a language that Google had been pushing very hard a few years ago, and nowadays it's not so much. Does anyone know why they pushed it so hard a few years ago? Oh, it had nothing to do with server-side programming or browser clients. They were worried that they might lose the lawsuit against Oracle for Android, and they badly needed a plan B for Android. So if they had lost the lawsuit, we all would be doing Dart programs on mobile phones. But they won the lawsuits, and well, there's one appeal pending, so they might still lose it, but it's unlikely. So that, and actually now they're coming back and say, yeah, they now can do better Dart programs, faster Dart programming on Android phones than with Java. So who knows? But so this idea of generating JavaScript is in the air. It may well be coming. And so you're seeing, the first, really what I think the first credible implementation that I've seen. All right, so in the next lab that we'll do after the break, what you will be doing is you will be taking the the Scala program that we did before with the to-do list. Now that Scala program generated HTML, if you think about it. So there's that Play program. It generated a bunch of HTML, shipped it to the client. That's so last millennium. So we're going to first of all rip that all out and make it so that it's purely a service, that one accesses the server and says, hey, here's a new task. Delete this task. Show me all tasks. And it's just done by posting and receiving JSON. Then we'll hook up that Scala.js client to it, and you'll get a very rudimentary application that gives you a way of doing the task list. And when you run it, you'll see it is actually amazing that A, it works, which is amazing, and B, the update is completely instantaneous, and even in its primitive form, it looks smoother and nicer than what you've seen with just using Play. All right, so let's have the break and then do that programming.